Welcome back. In the previous episode, I introduced the car, and the reason why this project exists. An alternator problem that had already appeared in the past. Back in July 2017, the car underwent a major charging system repair. After confirming the fault, the alternator and the power module were replaced. Years later, in 2022, the car developed another charging system issue. Once again, the alternator system stopped working correctly.
Okay, so BMW has a problem with charging the battery, so we need to disassemble a few things and go to get access to alternator. Won't be easy because there must be few steps done before. So yep, let's go back. Let's go to the work. I need to take off intercooler, fan, and then I'll have access to the pulleys and to alternator. Okay, so the fan removed. Of course, there's problem to remove this one because pump rotate with the nut, so it's not that easy. I try to block the crankshaft, but the pump rotates over the belt. So yeah, I just removed 3 bolts from the fan. And here it's coming, alternator. Okay, now I have better access. I need to use 2 times key, 30 to 32, or clamp to. Oh yeah, it's hard to remove it. I should remove this hose first. It's very heavy and doesn't have so much room here. So yeah, maybe I need to remove this charge air pipe. Since I don't have space from the top to take alternator, I need to remove this hose from the intercooler, and then I hope there will be much more space from the top. If not, maybe I'll take off intercooler because I can't remove this fan, viscosity fan. This alternator looks kind of new. So I'll test right now alternator, but I can see already the bulb doesn't blink. It's not on. From battery is 12.8 volt, and the positive is supplied to 2 pins, the big one and ignition, so to say. And let's run. Nothing, doesn't charge, but I can see this already, that bulb doesn't turn on, so not good.
To properly test modern alternators, you must control the regulator using a dedicated tester computer on a test bench. My initial test was incorrect. I applied a simple 12-volt supply through a bulb, an outdated method that cannot properly excite modern alternators. Without the correct control signal, the alternator will not start charging. Now, it's time to test it the right way. To eliminate any doubts, I sent the alternator to a professional company specializing in alternator diagnostics and repair. After a full inspection and proper bench testing, the result was clear. The alternator was working correctly. There were no faults. No failures. No reason for it not to charge. Which means the real problem lies somewhere else in the car. And now, the search for the true cause of the charging failure continues. Now, I'm taking a closer look at the engine control units. And I immediately notice something important. The DDE control units have been replaced. This means that someone in the past was already trying to fix the charging issue. At some point, they believed that the problem was not the alternator itself, but the engine control unit. More specifically, they suspected that the DDE was not sending the proper excitation signal to the alternator, the command required to activate the charging process. This suggests that the charging failure was not a simple mechanical fault, but a deeper electrical or control-related issue. And it also confirms that this problem has been ongoing for years. Now, the question is no longer whether the alternator works. The next question is simple. Are the wiring and connections actually okay? Because even if the alternator works, and even if the control units are functioning properly, the system still depends on one critical element, the wiring harness. Now it's time to check the continuity of the wires between the alternator and the engine control units. Every signal, every command, and every feedback line must travel through this harness. If there is a break, corrosion, or high resistance anywhere along the path, the alternator may never receive the command to start charging. This is the next step in the diagnosis. To verify that the alternator and the engine control units are truly connected and able to communicate. Only then can we move one step closer to finding the real cause of the problem. After carefully checking every pin and verifying the continuity of the wiring harness, the result is clear. The wiring between the engine control units and the alternator is okay. There are no broken wires, no interruptions, and no communication faults in this part of the system. This confirms that the control signal can reach the alternator, which means the problem must be somewhere else. Now, attention shifts to the main positive power cable. This is the primary power supply line, running directly from the battery to the alternator, and also to the glow plug control unit. This cable is responsible for delivering the main charging current and supplying power to critical engine systems. And now, we can finally see the real problem. The main power supply cable is heavily corroded. At the branching point, where the cable splits and feeds both the alternator and the glow plug control unit, the damage is severe. The corrosion has completely weakened the structure of the wire. In fact, the cable had degraded so badly that it could be broken apart by hand, with almost no force at all. The wire simply snapped and fell apart completely. This level of corrosion makes it impossible for the charging current to flow properly, even if the alternator is working, and even if the control units are sending the correct commands. The electrical power simply cannot pass through a cable in this condition. Corrosion and heat damage on the main power cable. This is bad. To replace this cable, access is extremely difficult. The wire runs along the rear of the engine, passing between the engine block and the automatic transmission, right where the starter motor is located. This area is buried deep inside the drivetrain. There is almost no space to work. Access from above is nearly impossible, and access from below is just as challenging. To reach it properly, a large portion of the lower engine area would need to be disassembled. According to the official service documentation, the recommended procedure is to remove the transmission entirely. Only then can the cable be safely accessed and replaced. This is not a simple repair. This is a major operation. But if this cable has failed, I need to find a way. Please look how bad this cable is. But before committing to such a major repair, I want to make absolutely sure that this is the real cause of the charging failure. Removing the transmission would take a huge amount of time and effort. So instead, I have another idea. As a temporary test, I will extend the power cable from the point where it broke. This will allow me to restore the electrical connection without fully replacing the original cable. The goal is simple: to confirm whether this damaged cable is truly responsible for the charging problem. If the alternator starts charging normally with this temporary connection, then the root cause is confirmed, and I can move forward with confidence, knowing exactly what needs to be repaired. The idea is to clamp a new cable onto the original one, at the point where the wire is still in acceptable condition. This will allow me to bypass the damaged section and restore proper power flow to the alternator. To do this correctly, I need to use a cable with the exact same cross-section, capable of handling the same current load. And I will also need special high-current clamps, designed specifically for this type of connection. The biggest challenge, however, will be access. The cable runs deep behind the engine, and reaching it safely will require removing components in the way. Most likely, the intake manifold, also known as the intake plenum, will have to be removed. But since the intake system will already be disassembled, this creates a perfect opportunity to perform another important maintenance step: cleaning the intake ports using a walnut blasting machine. Over time, carbon buildup restricts airflow and reduces engine efficiency. Cleaning the intake ports will help restore proper airflow and improve overall engine performance. So this repair is not just about fixing the charging system. It's also an opportunity to improve the engine's condition at the same time.
So yeah, to renew cable, positive, from battery to alternator, I need to take off the intake plenum, intake manifold. So I unscrew a lot of things around and I need to take it off. But I need to watch out that nothing will drop to the intake slots, because then it will destroy the valves and engine will be kaput. So I took off intake plenum, intake manifold, and of course a lot of crap inside. And the sphere flaps has broken guidance, so they couldn't work, and they are not closing fully. Let's see this side. Oh, they're stuck. So I assume they were just open in this position and nothing happened with them. So yeah, intake plenum, intake manifold taken off, and you can see ports to intake valves, and the last glow plug, or what left with this plug. Juicy, a lot of juice. I checked the resistance of the glow plugs, and from 1 to 7 they're okay. The last one, number 8, doesn't show any resistance. The rest shows 0.9 ohm, 1 ohm, so they should be in spec. So I need to replace the last one and also repair the plug itself. So I'm looking on this positive cable, and it's really bad. So I hoped that until he'll be good, and then I can renew it from here and supply to alternator and to glow plug unit. But it looks so bad, so maybe I'll need to flash the coolant, remove the exhaust cooler, so I have better access to rest of the cable. The best would be to exchange, of course, full cable, but to do it, in the instruction it's written that you need to take off the gearbox down, DPF down, and starter, so there's a lot of work to do. I need to think what to do, what's the best. So now on, it will be very good to check all wires that go from the plug of the glow plug unit to each glow plug, to see if there is passage. Okay, I checked the cable and the wires for each glow plug. From the socket, 8 first from the left are going to the head of the glow plugs, and they are okay. All of them have passage. So yeah. So now I need to remove the sphere flaps from the intake manifold. Already the drive unit that stir the flaps is removed, sensor is removed, and now I'm just removing the plastic flaps from the manifold. So the sphere flaps are removed, and you can see how much nasty it is inside. Very, very clogged and nasty. Unfortunately, in BMW you can buy only full set, and it's around €2,500. You can't buy simple parts because I have broken these two plastic shafts, so the steering device, which is here, is not able to play with the sear flaps. So maybe I could try to apply some metal bars, but I think I will just blind the holes with special kit and just get rid of all sear flaps. Oh, look, there's intake valves. I think I will need to use here walnut blasting, so I need to buy a machine. Right now not super expensive, but definitely I need to do some cleaning here in intake valves because they look horrible. They look delicious. Valves, very delicious. I'm checking the next one, and it's not so bad like the previous one. So yeah, let's check all of them. In one port I can see some object. I'll try to vacuum clean it, suck it out.
In the next episode, we take the next step deeper into the engine. The intake manifold will be removed, revealing years of carbon buildup inside the intake ports. Using a walnut blasting machine, we will restore proper airflow and bring the engine one step closer to its original condition. This is a good and proper maintenance of each diesel engines. See you in the next episode.